So I've been working for doing like the visualizations for Porsche for more than 3 years, and I was living in a place called Azores in the middle of the Atlantic Ocean, and I was getting so frustrated with the local market. It was so small that I decided to move to Germany. And when I moved out to Germany, I had to deal with a lot of barriers, such as, okay, you need to prove what you're able to do in a market that it's already like with people working in the area. So I decided with my first paycheck to buy a motherboard, and with the second paycheck to fill it up with graphic cards. And I could just manage to do my work without needing to use any kind of render farm or even it was faster. So slowly I start doing a takeover and showing stuff that will be possible to do for Porsche. And what I've been doing, actually, it's exhibition communication. And we had a problem at least at that moment, because when they started making calculations about render farms, they realized that they were going to spend a fortune on rendering. And the only way to solve this was buying a render farm, a low-budget render farm. So you can get something like this for less than 10,000 euros. And I'm going to show the advantages of getting a system like this. So basically what I got was to get a rack server and fill it up with 1080s. And GPU is quite new in the market. Somehow it's showing up now. Has been for a while, but nobody is really talking that much or using it for production. You just see like small stuff being done with GPU, but I think it's perfectly able to for production. There's some limitations, but of course there's always ways to turn around. And I would like to just make like a jump over the few stuff that we are doing for Porsche. And there's no limitations with the resolution. Like you've seen on a few frames before, I'm working with massive LEDs, and we always have like from 8K to 10K resolution. So there's no way that we can use CPU for this. I mean, we could, but it will take ages. Plus, we are working with 50 frames by second. So anybody here that is working with video, they will have like a short idea about the render times that we are talking about here. But using GPU, in this case Vray, CUDA technology, I'm getting like in 10K, I'm getting like 35 minutes completely noiseless frames. Noiseless, it's really, really nice. 20K, okay, I'm rendering 20K images in approximately 1.42 hours. Okay, using a CPU, it will take ages. Probably like take like, I don't know, 24, 48 hours to render such a picture. Okay, interiors. I mean, as long as if you have enough memory on your GPU, you can fill up any geometry you want to. We are working with CAD data. CAD data sometimes can be pretty heavy. I mean, sometimes we get like 8-10 gigabytes of mesh, and you really need to fill it up in a GPU. As long as if you have enough memory, it can handle. And the render times are exactly the same. The only difference is that it takes a while to compile the geometry to the GPUs, to the memory, but this while is nothing more than 5-10 seconds. So it's not really a big deal. And of course, again, render times. This is a 4K picture. No noise, 5 minutes. Depth of field, it can manage the same way. I don't see that depth of field will be a problem for the GPUs. It's never been since the beginning. So you can get exactly the same quality in 3 minutes. Using 1080s. It's 3 minutes by picture. Directional lights, I mean, there's a lot of features that it's already available for Vray RT. And RT is slowly getting close to advanced mode. I mean, there's a few features that they're going to launch on the next release. I'm going to show one of them that I really appreciate. Well, in this case, we already have directional lights. It was on the last, on 3.5, came out with the directional lights working on GPU. And again, it's a 4K image, and it took me again like 4 minutes by frame. And it's, yeah. I mean, if I will use a CPU, it will take me, I don't know, I have a few benchmarks later, but I don't want to make any rough calculations. Like, okay, it will take like 1 week, and 1 week is guys crazy. No, but 4 minutes with a GPU. Okay, this is my favorite feature. I mean, the Chaos Group support, it's amazing. I mean, we have a forum, and I'm testing all the nightlies that they're launching every night, and they're always dropping new features. And the feedback that they got, if there's any bug, it's fixed on the next day. Okay, I have a few coworkers that are working with me, and they are working with some competitors, other render engines that I don't want to mention, Nate. And sometimes they send feedback and the reports and blah blah blah, and like 1.5, 2 weeks later, sometimes 1 month, it's fixed. But okay, congrats, Chaos Groups. They are amazing, really. They are always on top of the line. Volumetric light. Okay, it's working in RT right now. I'm totally addicted to volumetric light. Every time I have a chance to use it, I just use it. I don't even think twice. I just drop it over there. This is a backplate that we are working right now. And it's supposed to, there's a car on the right, but it's not there yet. It will be soon. And again, this is still on a light lease. Volume light will be launched on the next release, probably. And 7 minutes by frame. Again, 0.6 of noise. It's almost clean. Okay, match shadow, it's just a different picture. 3 minutes by frame, and we are talking about 4K resolutions. Okay, now it's time to just start showing less and show the advantages. In my office, we have 2 workstations for this amount of price. Okay, so we spend like 10,000 on 2 HP with 4 Xeons, and with the same amount of money, I could manage to build my farm, and my farm was about the same price. Okay, 100 euros expensive, with 8 Nvidia 1080, and now, okay, yeah, and the price that you can compare, like the price of a nice Xeon CPU with a standard graphic card, 1080. It's an awesome graphic card for the price quality, what you get out of the box. And I decided to buy 8 for the farm. And if you just make a rough calculation, the amount of CPU that you had on the 2 other workstations, it's more expensive than 8 1080s. So for the same amount of price, I could actually fill it up or drop more 4 1080s here on the corner if I wanted to. And it's a lot of power. Everything that I showed until now, it was just using 8 graphic cards. If I will drop 12, 16, or just escalate this way, it will be insanely fast. But I don't need. Sometimes you just go home, you just leave the machine rendering over the night. You wake up in the morning and it's already rendered. So it's taking 8 hours. If I will get twice the graphic cards, it will take 4 hours. For what? I still need to sleep, right? Everybody needs to sleep. And okay, yeah, okay. Let's start now with the benchmarks. I did a few tests with the advanced and GPU, and I tried to match exactly the same amount of noise. And I used the 4 Xeons that you saw on the test before, and I used the 8 1080s. And this is a difference of time. And attention that this scene here is quite dark, and GPUs sometimes they have some problems cleaning the noise on these dark areas. Not anymore, because Vray has adaptive lights right now, and the algorithm and the kernels to kind of like read the image, it detects where it's too dark and it drops more power there. Okay, so it's adaptive. So if part of the image is clean, it just focuses on the dark areas and so on and so on and so on. That's what it makes Vray so fast. This is like a crop from the render that you saw, and this is the amount of time that I could get in the GPU, and using a CPU, I could get like for almost like 3.5 hours. So it's 6 times faster. Interior's exactly the same. I mean, there's like it's 5 times faster, even with depth of field. And the magic really happens. It really happens. It's on bright scenes. You get really, really a massive boost of speed. because there's almost no noise to clean. So it's insanely fast. I could get 10 times faster, the same render time. Yeah, this is one of the things that I really felt it was most impressive about RT. If anybody knows here, and if anybody is rendering and working at the same time, you know that once you press render, you can go out and take a coffee. You cannot do nothing with your machine. Your machine is completely frozen. You can barely browse, right? Using GPUs, there's no loss of power. I mean, you're just feeding the GPUs with information. Your CPU, it's completely clean. You can do whatever you want. I'm working. I'm exporting EXR straight from the frame buffer from Vray, and I'm compositing at the same time in Nuke. So it's amazing. I mean, it's really incredible. I can really render on my machine. I can work at the same time. And even if I'm going to render from Nuke straight to my drive, while I'm rendering at the same time in Max using the GPUs, you don't see any drop of performance. Because the GPUs, they don't need that much power to be fed. They just need the scene. Once the scene is over there, it's just render, basically. It's really, really insane. It's one of the focus. Because you have a workstation, and while your workstation is rendering, it still is a workstation. It's not a render farm anymore. Learning curve. If you have a viewport showing everything that you're doing, instantly, straight ahead, like light a scene or just change a shader, you will work smarter. I mean, if you need to re-render and re-render the same scene until you get exactly the same picture that you wanted from the beginning, or if you want to, for instance, there's so many situations that I'm just working on the same scene, and once I find the balance between light or shading or whatever I want to, I just wait like 1 minute, I export the XR, I compose it, and it's done. I don't need to re-render, I don't need to wait for light calculations again, I don't need to, I'm just working straight ahead on the active shade. And I just export the same frame from the active shade if I'm working on an active resolution using GPUs. I don't need to render. It's really, really fast. Yeah, and deadlines. This is like the most awkward part of, you know what I'm talking about. There was one time that I was working, and it was like, we had like 48 hours until the opening of the exhibition, and I got a phone call saying that the rims from a specific car on a 15 seconds render, they were wrong. So they had to change the rims on the last minute. And how could you manage to do that if you would just use a CPU, if you have your own render farm on a, I mean, it depends on the budget that you have. You can, of course, you can get like 500 CPUs and you can do the same job. But I'm talking about 81080s. They can manage to do exactly the same work. 81080s, eh? It's amazing, you know. You guys, no. Okay, I'm gonna just go away from this slide. We are talking about 81080s. It's 8 graphic cards made for gaming. They cost like 500 euros, right? And then you compare it to all these guys that are like spending fortunes. I mean, if you want to get a dual Xeon, you need to spend on a motherboard, power supply, you need to have onboard graphic cards, you need to have RAM, you need to have all of these. So if you want to get 4 CPUs, you need to have twice the hardware, right? There are rack servers that can already handle with 12 graphic cards. So I can get 24 graphic cards with 2 pieces of hardware. It's a lot. I mean, it's crazy. I mean, if you ever had the chance to work on a machine with 8 graphic cards, and if you're an artist, and if you're creating light, if you're shading, if you're animating, or if you want to grab a play blast straight out of the viewport, you can do it really fast. And so I would say that it's even funny to work when it's about lightning and so on. Yeah, give me deadlines and some GPUs, of course. And okay, now this is going to look like more like a V-Ray presentation. I've been working with V-Ray very closely since the first version, since they started doing production with it. And when they dropped the render elements working, they really make it official as a production render because you could actually use it for compositing. And since then, the evolution it was really, really nice. They start dropping stuff that I don't want to talk about all of them. It doesn't make sense. I just want to show all the effort dropped by the GPU team on the RT render engine. And these were the last releases on the 3.5 here. And they got stuff like as a matte shadow catcher, adaptive lights. You know, it's so much faster to render. Render mask, stochastic flakes, directional rectangular light, aerial perspective, and slowly the gap between what is available on CPU or what is not still available on GPU is getting smaller and smaller and smaller and smaller. And with the 10,000 euros, I could manage to build my own render farm and render in 4K. Since the beginning, I did that. Oh yeah, and now I'm going to show what this piece of shit that I have here. It's a 3 years laptop that I have here. It's a 850M, the graphic card, and I'm going to render on RT on an 850M. Okay? Yeah, okay. And I have a 850M, it's a GeForce, it's still okay. It has 640 CUDA cores. It's the one from my laptop, like I told before. And the farm that I have, it has, as you can see, each 1080 has 2560 CUDA cores. If I multiply by 8, I have 20,000. So whatever you're going to see from now on, you need to just speed it up on your brain like 32 times. Okay? And it's going to be fast. 32 times. So this is a full HD frame. It's already nice for preview. And as you can see, 560 CUDA cores, they are really cleaning the noise. And now, imagine 32 times faster. Okay, and you can change stuff on the fly. I mean, I think that you guys already got the idea, right? I mean, I'm working on a laptop. This is not a workstation, and I can still manage to work on it. And I could open Nuke right now and just export a EXR and compose it on my laptop. There's no drop of performance on the machine. And that's it. I mean, I think that's it. Yeah, I'm a GPU fanboy. And I will like... and I will...